Hi friends, this is the third video on Taguchi loss functions or quality loss functions. So here in third video you talking about type of quality loss functions or Taguchi loss functions. So here the first type is nominal the based loss functions. Second one is smaller the better loss function. And third one is larger the better loss functions. So what is the first kind loss function is saying that the first one is nominal the based. If loss cost is C, then what will be formula? The loss of y equals to k in simple bracket y minus m to the whole square. So now here we are putting t, y minus target value. T is the target value. So if you calculating loss k, it will becomes out c cost, loss cost equals to c divided by y minus target value to the whole square. You see y minus t is taken as delta t because of tolerance range. So here I am taking tolerance range. Okay, if you see that like 15 plus minus 0.5. So in this case 0.5 is putting here, then whole square of this 0.5. So this is one of the formula for the nominal the based. Now the second one is smaller the better. So loss of y equals to k minus y to the whole square, where y equals to observed value. By conventional method, if the quality characteristics QCH is below the upper limit, then there is no loss. If the quality characteristic is below the upper limit, then there is no loss. But if quality characteristic is above the upper limit, then it will be loss something like C. So in this figure you see here, this is a y-axis shows as cost L, loss L, and cost is given is C. And this point is known as quality characteristics as y observance. So this curve is known as loss functions, and this is the quality characteristic is less than upper limit, then there is no loss. Okay, so here this is delta t is the allowable upper limit. You see here friends, if you see in this picture very precisely, then you see that if here, then there is a very less loss, but goes from here, then it will be having some more loss. If goes here, then it will also having some more loss, here some more loss, and you go here, then it will be more loss, and here more loss. So if you goes inside this, then loss will be comes very less, but if you goes in this direction, then loss will be increases. So this figure is shows as smaller the better loss. Now the third one is larger the better loss function. By conventional method, if quality characteristics is above the upper limit, then there is no loss. If quality characteristic is below the upper limit, then there is some loss as C. So you formula given here, loss of y equals to k in simple bracket y divided by 1 divided by y square. This is the formula of larger the better loss functions. And in this case you see here delta t is the allowable lower characteristic lower limit, and this is y-axis, this axis horizontal axis shows as quality characteristic, and y-axis shows as loss, and given is C. This is a loss function del Ly. In this case quality characteristic is greater than upper limit. In same, if you goes inside this, then loss will be less, and if you goes in this direction, loss will be increases. So some formula you notice in mind friend. The first one is if single product loss, then formula this is used. Here for single loss product, you given as formula is given as loss of y equals to k in simple bracket y minus t target value to the whole square, and if you calculate it, then it will be comes out like this in last picture. From here you see Now if loss having multiple products, then what will becomes out? The formula will be becomes loss of y equals to k in square bracket variance square plus x bar, this is the average values or mean, minus target value to the whole square. So this is the multiple product losses and this is a single product losses. So this is a formula which is used in next video by clearly how can use this formula. So thank you.